Welcome friends. In today's video, we are going to see one of the important concept in Java collection framework, which is linked list. So linked list is a class in Java collection framework that implements both list and DQ interfaces. Means internally it implements list and DQ interfaces, making it versatile and flexible collection. It is a one of type of versatile and flexible collection. It is part of java.util package, provides double linked list implementation. Then we are going to see some key features of linked list. Let's understand this with some key features. What is doubly linked list? Each element node in the linked list contain a reference both to previous and next element, allowing for efficient insertion and deletion at both ends. Means it allows us to we can get element in both the end because it is implementation doubly linked list. So we can access middle of the element in the faster orders. It implement list interfaces, supports all operation and list interface such as adding, removing and accessing element. Yeah, it will implement a list interface internally, so we can perform all the method which is in list interfaces, that is adding, removing and accessing elements. Implement DQ interface, support operation of DQ interface such as add first, add last, remove first and remove last, making it useful as both stack and queue. So we can use for this add both stack and queue. Dynamic size, the size of linked list can grow and shrink dynamically as elements added, and as soon as we add it fills linked list, it will dynamically add or size of the linked list will grow. What is the advantages of this? Here we can see insertion and deletion, efficient insertion and deletion. Insertion and deletion are efficient, especially at the beginning and the end. The list will take the time complexity loss for a list is omega of 1, and compared to array list which has omega of n. This is for linked list and this one is for array list time complexity for these operations. So no initial capacity. Unlike array list, linked list does not need to reserve a large continuous block of memory initially. Means we don't need to suppose, yeah, like we can mention array equal to, and we need to mention size in advance for the array list. So that is not required for a linked list. It is automatically grow and shrink. And disadvantages for this is slower time access, as it is access time is slower, omega of n time complexity compared to array list omega of 1 time complexity, because you have to travel the list to access an element by index. Means in the middle index we need to access, that will take much time, so it is slower as compared to the array list. So more memory overhead. Each element in linked list require additional memory to store a reference to the previous and next element. Means we need to store element previous and the next. For that we required more memory as compared to the array list. These are the advantages and disadvantages for the linked list. Let's understand this with example. Some common method we are going to see here first, which are the common method in we linked list we can use. So let's see here. Add element. Yeah, add element is method which will give us append the specified element at the end of the list. So we can element A, which will append, it will append element at the end of the list. At the end of the list. So next method is there. Next method we can see add with the help of index we need to use. So we can use add int index and e element. So add int index and element. So what this method will give us, add int index and element, insert the specified element at the specified position in the list. It will insert the element in the specified position in the list. These are the usages of these methods. So one by one we will see all the methods which we can access. Let's use another method. Another method is remove int index. So remove integer and index we will use. Yes, it will remove element from specified list. These are the some of the methods we can use in linked list. There are several like get int index, add first, add last, remove last, get first, get last. These are the method we can use in linked list. So we will understand this one by one with example. Let's see the example. With the help of example, we can better understand this. So linked list. I'm creating here linked list object, so we can add some element into that link. Linked list equal to new linked list. So linked list dot add. What is the method we have seen here? Here we add element, which will we can add element into the linked list dot. It is a type of string, so we need to mention it is a type of string, linked list of string, and we need to add. Why it is not taken? It is a type of generic linked list dot add. Why it is not taken? We have used same class name. We will rename this first. Now we will try to use this and we will implement this linked list. Now it should give us the method which we can add element. So we can't use predependent classes as a class name. So here I am using, we am adding some element, suppose element one, and we'll copy paste this for faster execution. Element one, element two, element three. Now we have added element into our list. We will add element at specific location. So here element at specific location. So we are using here linked list feature. Linked list dot add first. Add first method is there. Add first. So we can add here first. Linked list dot add last. So we can add element last. Let's run this code and we will see the example. And after this, we will see how we can access element from the list. Yes, element from list. What happened here? We have not printed this, so that's why it is linked list. We can print. How we can access? Yes, how? Access first element, and linked list dot get first. Then we will use copy this and we will use last element index. We will access one last element and index element. We will use index get first and here get index dot get and index we will mention. So let's rerun this and we will see if we get the expected output. Next, we will see how we can iterate element in the linked list. So here we are able to access first element, which is first, access last element. So here we have not used last, get last, and get index element is a add element 2 in the index, which is 2 element 2, which is printing. And now we are going to see how we can iterate over the linked list. Iterate over linked list. So for that, we are going to use a for loop, which will give us element from the list. For here we got the last, and here we can see for linked list we are using. So link yes of linked list, and we will print this as out. Yes. So we will have element in our thing. Better we will use here element. We will element. Let's run this and see the output for the code. Here if we see, we got the elements in the list as per we have inserted. This is the first. This is element 1, element 2. These two we have laterally we have added first and last. These three are already there. That is these are the use cases of the linked list. And when to we use linked list, we will understand this. Like our frequent operation is insertion and deletion we can go with linked list when your application frequently insert delete element, especially at the beginning or end of the list. Less frequent random access. If you do not need to frequently access element by their index, to slower access time of linked list compared to array list won't be significant drawback. So that the conclusion it is like whenever our operation, frequent operation is insertion and deletion in the end or beginning, in that case we can go with linked list. Let's see the comparison of the linked list and array list, how we can. I will use here. We'll create one table which will give us comparison between uh, linked list and array list. Here I am showing this for demo purpose only. So feature here linked list will be there here, linked list, and here array list. And underline data structure for this is for a linked list is double linked list and array list is resizable array. And for this arrow, resizable array. Next big difference access time is for array linked list is omega of n, and for array list is omega of 1. So access time omega of n means it is higher, and for this it is lower, and we can faster access for the arrays. Then next is next insertion deletion. And it is a reverse in array list and linked list. For this it is omega of 1, and for this it is omega of n. Then next is memory overhead, higher as in linked list, and lower in array list. Means higher. Why it is higher? Because we require high memory to store first previous node and next node, but as compared to array list, it is not required. Then next is use cases. Frequently insertion and deletion, we can use linked list. If we want to access frequent access by index, then we can use array list for insertion and deletion. And for frequent access of the index with the help of index. With the index. These are the use cases for comparison for linked list and array list. I hope you gain some knowledge from this video, guys. Thanks for watching this video. If you like the content of the video, subscribe to the channel. Thanks for watching. Like, share. Thank you.